Okay, we're going to talk about predicting products today, and so that's kind of a tricky thing, but it's the ones that you'll see on the test, quiz, things like that. They're going to be more straightforward. So let's just kind of run through some example problems like you guys are going to see. And so the first thing we have to do, and I've just got right here, I've just got a few of the example problems. So this is just a few problems for us to look at. So the first thing is that you have to identify which type of reaction you have, because if it's decomposition or if it's synthesis or combination, is it single replacement, is it double replacement, or is it combustion? And so if you know which of these things it's going to be, you're going to be in a lot better spot in terms of trying to figure out what the products are. So if you look at these problems, see they are missing the right side. So like this is totally gone, and we have to fill in these things, which this is the missing products. And so we've got to go through and we've got to fill that out, and we're going to have to come up with an answer. So I'm going to go through some of the ones that are maybe going to fit our five types, and all of these do, but I'm going to do each of them to give you guys an example of each of them, and then you're going to go back and you're going to try and figure out how to do the other ones. So let's go ahead and take a look at these problems here. So let's take a look at number two. And number two is it's got a couple of chemicals over here. So it's like, oh, we've got a chemical here and a chemical here. So we got two reactants. And really, what can they do? Well, they can't switch because there's nothing to switch with. They can't combust. They can't break apart because they're already by themselves. So really, all they can do is go together. So this is going to be a synthesis or a combination, however you want to think about that. And so what's going to happen is over here, I'm just going to put these chemicals together. So here's Na, here's N. I'm going to crisscross them. This is a +1. This is a -3. Remember, I get that from my periodic table. And then I'm going to clean this up just a hair. And I'm going to crisscross them down. So it's going to be Na3N. And then I'm going to go ahead and balance it. And so the NAs, I'm going to go ahead and put a 2 here because I'm going to need the 2 for my ends. So I'm going to go ahead and do that. And then that gives me 6 NAs. And that should do it. 612. All right, so that is an example of a synthesis or combination. So what are you looking for? You're really looking for this. You're looking for a couple of items that are by themselves that are going to go together to make a single item. All right, so that's a pretty good one to practice with there. And another one here, and I think I'm just going to do number 3. Number 3's got some good things here. So there's only one item here, so it can't do any replacement, nothing to replace, and it can't combine because nothing to combine with. So if we got that one item over here, we know it's going to be decomposition. We know it's going to decompose, and so that makes this one pretty straightforward in that regard. So this is going to be decomp. So it's going to break into some things. So it's usually going to break into two things. It's pretty common. So what is it going to break into? Well, that's the hard part. So you know, is it going to break into Na and ClO3, or is it going to break into NaCl and O3? I mean, what's going to happen here? So these are kind of hard. I normally give you guys ones that are a little easier where there's just two pieces. So like kind of a hint, you can see this one here only has two pieces. So it's pretty easy to see what's going to break into. But what's going to happen when you see these chlorates like this is that you're going to have the NaCl over here and the oxygen over here. Now, oxygen's diatomic, and so that's kind of tricky, so you got to remember that. And then we're going to go ahead and look at our charges. So Na is a +1, and chlorine's a -1. So they go ahead and cancel out. Now, I would not give you one like this on the test. This one's a little more challenging than I'd give you on the test. This is the type I would give you on the test, like number 1, where that's pretty easy to see what that's going to break into. So number 1 you might want to write is decomp. I'm not going to give you guys the answer, but I think you guys can figure it out. It's just two pieces. But go ahead and give that one a whirl. Like I said, this one it's not like there's anything wrong with this, just probably a little more difficult than I'm going to give you guys on the test. Because the decomposition are always the tricky ones. So like if you're having trouble, just kind of do the best job that you can to figure it out. So let's go ahead and slide down here. Trying to look at different options we've got. I put some other ones on this page. I think I like this one here, number 11. Let's take a look at number 11. So take a look at number 11. This is an element and this is a compound. So we've got that element compound combination. So this guy's the element, this guy's the compound. So when you have the element compound, you know that over here you're going to have a new element and a new compound. And we just have to figure out what those are going to be. And this is going to be single replacement. So single is when you have the elements. And so with single replacement, what's going to happen is that this barium is going to either replace the front or the back. So you just check. So you look at barium and you look it up on the periodic table, and barium is +2. So if it's a plus, it replaces the front. So it's going to replace this hydrogen. So basically it's going to come over here. It's going to boot that hydrogen out. So over here, your new element is hydrogen. And then your new compound is barium. And your barium is with your sulfate. So now we have to, as good chemistry students, we got to look up the charges. We already know the barium. Well, the sulfate's -2. And that's actually convenient because, see, these are going to cancel out. It's going to be BaSO4. But now this one, we got to look at it. We got to say, oh, wait a minute. It is diatomic. So I'm going to have to come in here and add a little bitty 2, because the diatomics are for elements that are alone, which that is an element that's alone. So there we go. And then we've got to look at the balancing. Now this one's actually pretty darn easy to balance, because if you look, 1 barium on both sides, 2 hydrogens and 1 SO4. So it's already balanced. So not a big deal on that one. Okay, let's see what else we have. We need to take a look at a double replacement. So this one's a double replacement right here. Compound. And what is that going to make? Well, it's going to make a new compound and a new compound. So the difference in this one and the one we just did is that there's no element here, right? So there's no element. That's not an element. That's not an element. So if there's no element, then it's going to be the double replacement. So we got to remember what double replacement means. Well, that means the fronts are going to switch places. So this dude is going to swap over there, going to do a little switcheroo. And so now you have to come over here and you have to re-crisscross. And this is what students always forget to do. Is they forget to crisscross. You always have to crisscross when you make your new pieces, because otherwise the pieces are going to be incorrect. So let's put the calcium with the sulfur, and then let's put the hydrogen with the oxygen. Well, the hydrogen-oxygen one is really darn easy, right? Because that's going to make water, H2O. And this one, the charges are going to cancel, but here's the thing. They don't always cancel, so you do have to check, because like they didn't cancel there, right? We made H2O. And so you have to always check to make sure that you get the right combination. So let's say, for example, even though this is not the case, that we had aluminum combining with sulfur. Okay, well, -2 plus 3, well, that's a lot. That's going to make something that's very different. Now, obviously, we didn't have this. This was just an example, but that's why you always have to check for charges. Sometimes it works out, but sometimes it doesn't. So you always want to do your crisscrossing. So this is also real easy to balance. It's an easy one. 1 calcium on both sides, 1 sulfur, 2 H's, and there's your O. And so there you go. Not a big deal. But the double replacement, like number 5, that's also going to be double replacement. And I'll give you a hint on number 5, the NH4 and the H are going to switch. So that's what's going to happen there. So you guys can go ahead and try that one on your own. Look up their charges for ammonium. I guess I'll maybe help you out. Ammonium is sometimes hard to find. It is a +1. There you go. Make some new chemicals there. So let's do the last one. There's actually only one of these on this whole exam set of problems. There's only one combustion, so I'm just going to make one up. So I'm going to make up a quick combustion. So let's just do CH4 plus O2, and then they'd give you an arrow. And if you see this combination, it's always combustion, and so you always are going to have oxygen, and then this piece could be different. So like this could be like any combination of C's and H's. So it could be like C4H10. It could be C8H18. It could really be anything. I just made it methane to make it nice and simple. So, all right. So let's go ahead and finish this up. So combustion is actually pretty easy because you always have the same products. So if you can find this first piece, then you can figure out. Now this one is not on your paper. There's only one combustion on this example sheet, so I didn't want to do it. I want you to try and find it. But since I see the fuel and I see the O2, then I know that this is going to be combustion. So combustion always has the same products, carbon dioxide and water. No crisscrossing, no looking anything up, just put them in there and then we'll balance it. So it's always these two, which makes combustion so easy to predict. The products are always the same two products, right? So every single time. Now, there's only one of these on this particular practice sheet that we're looking at. So if you find it, you probably found them all. Like I said, I think there's only one. So carbons look good, 1 and 1. H's are 4, so let's put a 2 here. And then our O's are 2 here and 2 here, 4. So 2. So 1, 2, 1, 2. And then there you got it. That is predicting products.